This is the first of two videos that will serve as an introduction to the action potential laboratory that we'll be conducting in class. In the laboratory, we'll be using an interactive computer simulation of the neuron. This computer model is called MetaNeuron, and the interface for the computer model is shown here. Now, MetaNeuron incorporates many of the key properties of neurons, and it allows us to reproduce and recreate many of the key experiments that were done that have led to our understanding of how the resting membrane potential and the action potential are generated. MetaNeuron includes equations that simulate the properties of voltage-gated sodium channels and potassium channels. These channels have the voltage-gated and time-dependent properties that we have discussed in previous lectures. The model also incorporates leakage potassium channels that give rise to the resting membrane potential of the cell. MetaNeuron also includes membrane capacitance, which leads to the membrane time constant being generated, and there is a built-in stimulator which can activate the neuron, depolarize the neuron, and lead to the generation of action potentials. MetaNeuron, as you can see from the figure here, includes a display, a graph of the voltage versus time. This mimics what you would see in a real experiment if the results are displayed on an oscilloscope. And so the voltage of the cell, in this case an action potential, is plotted as a function of time. I would like to take you on a quick tour of the MetaNeuron display so you know how to interact with the program. There are 6 different lessons built into MetaNeuron that illustrate different aspects of the properties of neurons. These include the resting membrane potential, the membrane time constant, the membrane space constant, the generation of the action potential, and voltage clamp experiments, as well as generation of synaptic potential. So these 6 lessons can be accessed from this pull-down menu here. If you just click on lessons up here, you'll be able to select the appropriate lesson. This top area here is an area that includes the many different parameters that one can manipulate, and we'll discuss in the next slide how parameter values are changed. But experiments are done by selecting specific values for these different parameters. One of the features of MetaNeuron is that instead of selecting a single value for a parameter, one can click a box and select a range of values to be displayed. And the beginning and the end and the increment for these values are selected from this range window down here. If one chooses to display a range of values, then one can actually plot the resulting family of curves in a 3-dimensional graph, and that is selected by clicking on this button here. The graph of the voltage versus time is the main output of MetaNeuron, and as I've already mentioned, it displays voltage, the membrane potential of the neuron, as a function of time. And one can change the sweep duration, the total time that's represented on the x-axis, in this parameter box right here. And finally, one can measure the precise value of any point on this curve with a cursor. If one simply right-clicks on the graph, you will see cursor lines that come up, and you can select a point on the curve to measure, and then the x and y values of that point can be read in this box in the bottom right. There are several different ways that one can change the value of a parameter. If we look at this figure here, this shows the window that describes the parameters for the first stimulus that can depolarize the neuron. And there are 3 parameters that describe the stimulus: the delay to the onset of the stimulus in milliseconds, the width of the stimulus, and the amplitude of the stimulus. The number in the window right here tells you what the current value of the parameter is, in this case 0.5 milliseconds, and one can simply change this value by clicking on the number, typing in a new number, and then hitting enter. A second way of changing this, the value of this parameter, is to right click on this box here and then simply drag the mouse. If one drags the mouse to the right or upwards, this will increase the value of the parameter in units of 1. If one drags the mouse to the left or down, this decreases the value. If one wants to change the parameter value in larger steps, you can hit enter, you can hit shift and then drag the mouse, and then the number will change in increments of 10. And if you hit control and then drag the mouse, this will change the value in units of 0.1. A final way of dealing with these parameter values is to click to check the range box here, and in this case instead of the metaneuron program computing the result for a single parameter value, it will compute the result for a range of parameter values, and one can select in the range box, which was indicated in the last slide, the beginning value for the parameter, the end value for the parameter, and the increment value at which the parameter is incremented.